Welcome Calculus 2 students to the first of many videos. This first short video is intended to remind you of integration by substitution in a way that will help us introduce you to differential equations. So recall, if I have an integral e to the x squared plus 1 times 2x dx, that with substitution, we would use w equal to x squared plus 1 and conclude that dw is 2x dx, thereby yielding an integral e to the w dw that we could then anti-differentiate to find e to the w plus c, or if you prefer, e to the x squared plus 1 plus c. In general, if I have an integral of the form e to the f of x times f prime of x dx, then we let w represent the function f of x, dw represents f prime of x dx, which we get by differentiating. And so once again, we have an integral of the form e to the w dw. What's important is right now is for us to understand that this part, the f prime of x dx, that is our dw. We can replace the f of x with a y, and so if we had the integral of e to the y times y prime dx, that's pretty much identical to the situation we had a moment ago with e to the f of x times f prime of x dx. In both cases, the dw is the derivative of a function times dx. So we can replace the y prime dx with our dw if we're assuming that w is equal to y. When we make this assumption, however, it seems kind of silly to just change the letters. And so we remind you that instead, we can simply regard y prime dx as dy. And so anytime that we see this expression right here, we should feel comfortable replacing it with dy. And then we can regard this antiderivative problem as a problem of antidifferentiation with respect to y.